Hey, and welcome back to another video. So in today's video, we're actually going to be focusing on testing, which is a really interesting topic. So you may be wondering, or not fully understanding how to actually test your code that is asynchronous in unit tests. Well, in this video, as you can see on the screen, we're going to cover just that. We're also going to be looking at how we can test our async code in Swift using expectations, as well as how Swift concurrency makes our lives a whole lot easier when it comes to actually writing unit tests as well. So at the end of this video, you should have an understanding of how to test your asynchronous code, also how to test code using Swift concurrency, and also the benefits and everything that you should know and be aware of. So let's get straight into this video. Okay, cool. So what I actually have here is a starter project, and if you want to follow along with this tutorial, you can actually download the starter project from my GitHub, so you can actually follow along with me and have the source files. But what I just want to do is, I'm not going to go into too much detail about unit testing here in terms of the theory, because I already have a free course that covers that. I'll leave a link for on my website on the screen, so you can actually go and check out that course and learn more about the theory. But I just want to break down what we have in this basic project here at the start. So what we have here is just like a class that's basically simulating some kind of network call. So this isn't actually calling an API, it's simulating it with a dispatch queue. And within this networking manager, we can say how long we want the request to be and whether it was successful or not. And we have a function here called get data with a closure that basically tells us, if it was successful or not based on what we pass into this object. So this is just us mocking a network request. If you want to learn more about closures as well, I do have a video on my channel that you can check out. So what we're going to be testing, we're just going to be testing to see if when you actually make a call, so like it's not a real one, a fake one, but if you make a call, does it actually give us back what we pass into this object? So does the input match the output? So what we're going to do is, if you go into your test here, we actually already have a unit testing file in the starter project. And I just want to run this test. But before we do that, you'll see here that we have our system under test, which is our manager. We have our setupware and our teardown where we create it and we clear it. And within our test here for a successful networking call, we basically pass in is successful, the time of 10 seconds, and we have a closure here to check to see if the result is true, because we pass in true for the is successful. So we're just simulating a successful scenario. Now, what I want to do is I actually just want to run this test and see what happens. So if we run this test, you'll see that the test actually passes. But is this actually working? So you might think that what I've done here is all good and the test's actually passing, but you got a question, is this actually correct? Because there's actually a big problem with this code in this test. Now, what I just want to show you is that if I actually put a breakpoint on 29, because you would think that, okay, this is a successful test, but if I actually run this again with the breakpoint within the closure, you'll see that it actually never hits that closure. So this test is actually bypassing and skipping over this closure. So what's going on here? Well, what's happening is that this is actually being ran synchronously and not asynchronously. So what I mean by that is that synchronously, we're not actually waiting for something to finish. We're just basically just going and stepping through every single line. And then what happens is it says, oh, okay, there's not been a failure. Everything's okay. That's not what we want to test. We actually want to test to see if we pass in a time of 10 seconds. After 10 seconds, when we call our get data closure, does this return true? So this isn't testing what we want. And it's really easy for you to get into a scenario where this happens if you're not careful when you're actually trying to test asynchronous code where you need to wait for something to happen. So how do we actually wait for something in a test and, validate that? Well, we can do that by using something called an expectation. So I just want to open up the Apple documentation, and in here, you'll see that there's actually a, bit called asynchronous tests and expectations for XCTest. And this basically details how you can write tests for Swift concurrency, which we'll get onto later, as well as how we can actually also just write pure tests in just Swift if we're not using Swift concurrency. But what we want to look into is this class here called the XCTest expectation class here. Now, if you go into here, what this allows you to do is it allows you to create an expectation where you can essentially tell the system that I expect you to wait for a period amount of time, and then if the code fulfills, then that test passes. If it doesn't fulfill, then we will fail the test. So we're going to look into how we can use this API now within our unit test. So let's go back into our unit test. And the first we need to do is we need to create that expectation and give it some kind of name. So I'll type this out and then we'll break it down. So now we have our expectation and we create an instance of the XCTest expectation class, and the description here is essentially what it is you're trying to test. So in our case, a call network, it doesn't make sense in English, but a call to the network asynchronously. You can tell I got a bit lazy when I was typing, but basically that's what this is trying to do here. So now we have this expectation. We're not actually finished yet because we need to tell the system to basically wait for a period of time for this to finish. Now, in order to do that, there's actually an API called the waiter. So if you just scroll down on the documentation, there's this called the XCTWaiter, and this basically waits for a group of expectations to be fulfilled. So until an expectation is fulfilled, the test will actually fail, which is what we want. So we need to use this, and if you scroll down, you'll see there's a whole bunch of functions in terms of what you can wait for. So let's use this now. So if we go back into our unit test and we just say wait, you'll see there's this one, wait for. Now this takes in an array of expectations, but in our case, we're only working with one. So we're just going to pass in our expectation. And the timeout here is how long you want to wait for. Now, I want this test to actually purposely fail so I can show you that this is working. So we said here that the time for our request is going to be 10 seconds. So I'm just going to say 5 just so you can see it fail. Cool. So what we're going to do now is we also now need to actually call fulfill to say, okay, I want this to be fulfilled because it's met this condition. And we can do that by simply just calling that within our closure. So when you want your expectation to pass, you have to call fulfill, and you normally do this within your block or closure. So we're going to say expectation dot fulfill. So now we're saying here in our block that I want this expectation as being like successfully fulfilled. Carry on and actually check to see the asserts to make sure if everything else is okay. So when I run this test should fail because our timeout is 5, but we're saying here that we want to wait 10 seconds. So let's just run this. And you should see that it actually fails because you can see here that the asynchronous wait failed because it exceeded the timeout of 5 seconds. So we're now actually testing our asynchronous code. But if I was to reduce this, so let's say if I was to reduce the time to 3 seconds this time and actually run the test, you'll now see that our test succeeds. So we're now able to actually wait for our asynchronous code. So I'm just gonna put a breakpoint here just to show you that this is definitely, running and hitting the closure block here. So if we just run this again now, you'll see that we actually get it where our debugger stops within our closure block. So now we're actually testing what we need. What I would say is that if you're actually writing an integration test where you're interacting with a real API, I'll be honest with you, probably don't want to do that. But let's say if you are testing with a real API, use a timeout like 10 seconds or 5 to 10 seconds is a fair amount to use for an expectation. Cool. So we saw how to actually, write a test for an asynchronous function, but sometimes you might be in a scenario where you actually have nested functions where you need to test like the first closure and then another closure within that closure. So how can we, do that? Well, your first initial thought might be, okay, we're going to create multiple expectations, but you don't need to actually do that because if we just go back to the documentation for the XCT expectation, there's actually a property here called expected fulfillment count. And what this property allows you to do is it basically says that the fulfill function should be called this many times for the expectation to basically not throw an error. So what we could do is we could actually set the expectation fulfillment count to 2. And if it basically gets called twice, then we know that everything's okay. If it doesn't, then we know that it failed. So let's see how we can use that now. So we're just going to go back into our test. And then this time we're going to write a new test. And it's going to be, just going to copy this. Except this time it's going to be called test multiple successful networking calls. And then we're going to create our expectation. I'm going to say call multiple network async. And then this time on our expectation, we're going to say that we want the fulfillment count to be 2. Cool. So we want to set up our system under test, and we want to say that the first time that the test runs, it's going to be a successful true, and we'll set the time to 3, like so. And then we'll actually call our get data function. Cool. And then after our get data, we will use our wait for. Now, what I'm going to do is, because we're doing nested functions, just to show you this failing, I'm actually going to choose a really low number where I know this is going to fail on purpose. So I'm going to say that this should wait for the expectation for 3 seconds. So this will, if we don't call fulfill twice within 3 seconds, this test is going to fail. So within this get data, we're going to actually call fulfill and assert true like we did before, because we pass in true here. So we're just going to copy this and check to see if the result is true. And then within this nested closure here, we're going to now call the same function again, except this time, we'll call this result. We're going to call the exact same function, get data, but this time we're now going to set the system under test to false, so we can actually assert false, so we can see how this is actually, working with different values. So I'm going to say system under test dot is successful is equal to false, and we're also going to set the time here to be 4, just increase it by 1. So all in all, this nested execution should take 7 seconds. So if we set a timeout less than 7 seconds, this test should fail. So let's do that now. So we're going to call our get data like so, and then we're going to say result here, and then because we said we want to pass in false, we're going to assert for false. So we're going to say XCT assert false and then result. Cool. And because we're in a closure, we're going to say self dot and then also self dot as well. Cool. All right, cool. So now on our test successful multiple calls, we're not actually calling fulfill twice, we're only calling it once here. And also as well, our timeout is like really low. So let's actually just run this and see what happens. So this should fail. And you'll see that it fails because we exceeded the timeout of 3 seconds, which is correct. So if I now increase this from 3 to like 10 in terms of the timeout it should wait for, and we run this, this should fail because we've not called fulfill twice. Cool. And you can see here, this will now fail because we didn't call fulfill twice. We had unfulfilled expectations. So in order to fix this, all we need to do is here, when we have our false, we can just say expectation dot fulfill. So we'll call fulfill on our expectation, and then we'll start to assert our values. So let's just call this again. And this time this should pass. Cool. And now you can see that our test is successful and it succeeds because we call fulfill twice, and we also call this within the timeout that we set, because altogether this is 7 seconds, but our timeout is 10 seconds. Cool. Now, you might not have the luxury of using Swift Concurrency, but writing asynchronous code and also writing a synchronous unit test in Swift Concurrency is way nicer than using closures. So what we're going to do now is actually look at how we can do the exact same test that we just wrote now, but this time using Swift Concurrency. So if we just go into our sample networking manager, we actually do have our function here called get data. Now, something that's really nice in Xcode is that we don't need to start typing out the Swift Concurrency version. We can actually let this do it for us. So if you just hold down Command on your keyboard and click on the get data function, you'll see that you have an option here called add async alternative. So we click on this, you'll now see that Xcode actually adds an async alternative of the exact same function that we were using before. So now we get the best of both worlds, which is really nice, saves us a lot of time as well. So we're now going to actually see how we could write the exact same test, except this time in Swift Concurrency. So let's go back into our test file. When you're writing unit tests in Swift Concurrency, you don't really need to do too much. You just need to basically write the function signature and end it with the async keyword. So let's just copy the name of this. But this time, we're going to say Swift Concurrency, like so. And then we're going to write the async keyword. So now this is now going to use async await for this test. And in here, we can just say sut.isSuccessful is equal to true. We can set our timeout. So our time is going to be 3. And then we can now say our result is equal to await. Got to get data like so. Cool. And then we can just simply just say XCT assert true, like so. So looking at this compared to our example above, so if I actually just collapse this test multiple networking, if we actually look at these two examples now, you can see already that the Swift Concurrency version is just like way clearer and nicer to read. And if you want to learn more about Swift Concurrency, I actually do have a free course that you can check out on my website. It's on my YouTube channel, but you can check it out on my website. And I go over everything that you need to know when working with Swift Concurrency. So what we want to do now is actually run this Swift Concurrency test and see what happens. So let's just run this. And you'll see that our test passes. So all we had to do here was mark the function with async, and then we just call the function with await, and then we assert the values. Pretty simple. So what about if we need to do multiple networking calls like we were working with before? Well, it's the exact same thing. So I'm just going to copy this function signature name, and then we're going to use the Swift Concurrency, naming the test name. And then we're going to say async, like so. And then within here, we're going to say sut.isSuccessful is equal to true. And then the time is 3. And then we're going to say result 1. Don't cancel me. I know it's a really awful name, but please, 10x developers, don't cancel me, man. This is just purely for this example. So result 1, I'm just going to say await. System under test, get data, and then we're going to assert true with the result 1. And then for our other networking call, we just literally just repeat this code and that's it. So we can say sut.isSuccessful, but this time this will be false. We'll set the time to be 4, and then we'll say result 2, and then await. Get data, and then this time we will assert false with result 2. So now if we just run this test, you'll see that it works. And also again, comparing this to the nested version, you can see instantly that this is way more readable than all of this like nested this closure hell stuff that we have here. So Swift Concurrency makes this a breeze. Now, something else as well, I don't know if you've realized it, but when we're working with Swift Concurrency and we're doing, unit tests asynchronously, we don't need to say wait for expectations or using expectation. Marking it with the async keyword on the test is all we need to do, and we just use await. So this is, in my eyes, this is beautiful. So far, we've just been testing, Booleans with either true or false with a successful. So you can basically look at these examples as like we were testing values that will come back from an API. It's not actually testing if like an error is thrown or if something goes wrong. So we don't actually test like things going wrong with a case pass. So how will we do that in both of our examples? Well, what we're just going to do is just do a tiny bit of a refactor with our networking manager so we can actually throw some kind of error if something went wrong, so if it was successful or not. So let's go into our networking manager, and the first thing that we're going to do is actually create an error enum. So at the top here, I'm just going to say enum, and then we're just going to say my error. It's going to be a type error. And we're just gonna have a case here called, I don't know, custom. So for now, you can build this out more if you want to, but just for the purpose of this example, it's just going to be really, simple. So the first thing we need to do is we actually need to refactor our functions so we can actually now throw this error if something goes wrong. Now, if you work with closure-based, code in UI kit or Swift and you're not using Swift Concurrency, there's actually a, type called a result type that allows you to either throw, well, it allows you basically to return either a success or a failure, and that's what we want to use here. So on our closure-based example, we want to use the result type, but when we're working with Swift Concurrency, we don't need to use that result type at all. Instead, we can just basically make the function just throw an error. So let's just, work through that now. So on our get data function here, we're going to tackle this one first. So rather than this returning a Boolean, this is just going to return a string, which is simulating like, the result that you get back from an API. So we're going to change this to return a string. And we also want this to throw an error if something goes wrong. So we're just going to say this is now async throws like so. Cool. Now, at this moment in time, we're using a checked continuation, and with a checked continuation, that doesn't allow you to actually throw any kind of error. So we want to use a throwing checked continuation. So we're going to just change this from with checked continuation to with checked throwing continuation. So this will allow us to throw an error if something goes wrong. And then within our dispatch, we're now just going to say here that if self.is successful, or else here. So if it is successful, we're going to return some string because we're going to return a string this time, not a Boolean. So in the returns here, we can just say something like, data here. Doesn't really matter what you pass in here. It's just you returning a string. But in the else, if it's not successful, we can actually throw our custom error from before. So we're going to say continuation. We're going to resume throwing. And then in here, we're going to say my error dot custom. So this will throw the error that we created before. And because we're using a with check continuation, well, throwing continuation, we need to mark this with the try keyword. Like so. Okay, cool. So now this function has throwing capabilities and it will now return a value when we call it if everything is okay. So we've done that here with async await, refactored that. We now need to refactor our closure based example to either return a success or a failure using the result type. So rather than just returning a bool here, this needs to be result. So we're going to say result. And then in the result here, the first type that you pass in here is going to be string. So this is the value you want to, say in a success. This could be void if you wanted to, but we're just going to say string. And in here, we can now say the error, so the failure. So in our case, this is going to be my error. Cool. So after we call this, what we're going to say here now is we can now use a do catch. So we're going to say do catch. And because this get data now throws some kind of error, we can now just say try await. And if everything is okay, the result we get back from this function, we're going to return it using a success. So we're going to say completion and then dot success. And the string in here is going to be result. Now, if stuff goes left and it's not all good, what we're now going to say in here is we're going to just basically say completion. And then the failure here is going to be the error that we get back from the catch clause. We're going to say the error, and then I'm just going to hard cast this as my error. Now, I wouldn't recommend doing this in production. You want to do like some safety with like if let and whatnot. But the reason why I'm doing it as a force unwrapping is that I know this can never be any other value or any other type than my error. So this is fine for me to do here. But you can see here how we're now using the is successful Boolean to dictate whether an error is either thrown or if we return some kind of value. So now we're seeing we're simulating if something went wrong in an API. So now because we've made all these changes, if I hit Command B, I fully expect all my tests, they build successfully. I fully expected all the tests to basically be like, nah, bro, this ain't gonna work. It's not gonna happen. But we now need to refactor our tests to take into account the changes that we've made. So let's do that now. So what we're going to do is tackle our closure-based tests first. So in our closure here, yeah, there's the build errors. That's exactly what I was expecting. So in our closure here, what we're now going to do is that rather than checking to see if result has some kind of value, if it's either true or false, we're now going to check to see if an error was thrown or if everything was okay. So because our closure returns a result type with either success or failure, we need to use a switch case to check to see if there was a success or if there was a failure. So in here, we're going to say switch result, and you should see you have an option here where it does autocomplete, which is what we want. So now you have your success and your failure. So in this case, we want it to basically check to see the expectation not fulfilled within our success case. And then this assert true isn't going to be a true anymore because we're now, this now has some kind of string in it. So you could do a comparison on the string, but in our case, we're just going to say fulfill because we don't need to I'll treat you, man. We'll test the string. So we'll just say XCT assert equal, and we're just going to say data here. So we're just going to see if it matches that string. So we're going to say success. Cool. Now, if we hit the failure in this case, what we want to do is we actually want to fail this test. So we're going to say XCT fail. And the message here is good. We're just going to say you shouldn't hit the failure case, like so. Okay, cool. So now we have our first test working, and we're using the result type to check to see if there is a failure or not. And we don't actually need this associated value because we don't check it. So I'm going to remove this. So this is now working how I would expect it. So we need to do a similar thing, but this time for our nested closures. And you can see here that this is where this is going to start to look a bit messy because it's all like nested and it's a lot of code. So let's just, for time's sake, copy this result here. And then we'll just paste that here. Like so. Because successful true, you want to check to see on the success if it's okay. And this time, this is going to be a bit different here because we actually say that I want the successful to be false. So I want this to fail. So inside of here, if we just copy our switch block here, we actually don't want the expectation fulfilled to be within this success. We actually want this to be within our failure. And if we hit our success here, we actually want this test to fail. So now we can remove the expectations from here because we don't want that. So you can now see that with our examples, with our, no Swift concurrency, I'm just going to remove this. No Swift concurrency, you can use the result type to basically check to see if there was a failure in the success or the failure, enum cases. So it's pretty straightforward. Now, I want to run those two tests. So I don't want to refactor the Swift concurrency ones just yet because I want to show you this working. So just for this example, we're basically just going to comment out these two tests for now, and we're just going to run our test that we created before. So let's first of all run this successful networking, and what should happen with this is that this test should pass because it should hit the success clause and the assertion should be correct. So you can see here that the test is successful. So now we're able to simulate and test an API that either fails or is successful depending on what happens. And we go to the multiple and we run this, you can now see that this test also passes as well because we're checking to see in the success if everything's okay, and then we check in the nested closure to see if the fulfill was done in the failure. So if you're working without Swift concurrency, this is how you can basically test API code to make sure that everything is okay. But in my opinion, this looks ugly. This looks ugly as hell. So I don't like writing tests like this. So I'm going to show you how much nicer this is using Swift concurrency. So let's just uncomment our first one. And then this time, all we need to do here is that if we want to test to see the value and to fail this test if an error is thrown, is just use the keyword here, throws. So this will ensure that if an error is thrown for this test, this test will actually fail completely. So this is way nicer and clear. I just had to add that keyword. So in our await here, we just need to say try await, like so. And then in our XC assert true here, we can just compare this with an XCT equals like we did before. So I can just say XCT equal, assert equal, and we'll say data here. And then we'll just compare this to the result that we get back. So looking at this instantly, way nicer, way cleaner. So if I was to do this, where I run this now, you'll see the test passes. But if I want to actually show you an example of this failing because we're actually throwing an error rather than us going through the happy path, if I was to change is successful to false, you'll see now when I run this is that this test should now fail. And you'll see the test fails because we threw an error and we marked it with the throws. So this will help us capture any scenarios where it shouldn't throw an error. Really nice. So I'm just going to set this back to true. Cool. Okay, cool. Let's just run this to see if it's all good. Cool. So our next multiple successful networking calls, this function is a bit different because we actually want to test two things here. We want to test it if it was successful and if it fails. So if we just uncomment this, we do want to mark this with the async throws keyword because we want it to throw, well, we want this test to fail if the first part here throws an error, because this shouldn't throw an error. So we're just going to say try await. And then we're going to assert that the text is data here. So this should be result 1. So now if this throws an error, this test will fail. But if this throws an error, we don't want the test to fail. We actually want the test to pass because we're saying that we want this to be unsuccessful. So in order to actually test that out, what we want to do with this code here is actually wrap it in a do catch block. So we're going to say do catch. And we're just going to call this here. Now we don't need to capture the value here because we just want to see if this throws an error, which is what we want. So we're just going to use the underscore to not store it. And then we're going to say try await. Now, if we get onto the next line after this try await, what we do want to do here is actually fail the test. So we're going to say XCT fail because we want to say that this shouldn't be successful. So what this will do is this will actually fail our test and will basically ensure that, it's not successful because we want to basically make sure that when we hit the catch block that this is correct. So let's remove this. And then what we can do in here in the catch block is we can actually say XCT assert equal error as my error. And then we can compare to see if it's my error dot custom. So in the catch block here, if the error is what we expect, this should pass the test. So let's see if this works. So I'm just going to run this. And just something to keep in mind as well is if you don't see the little triangle in the corner, you just need to build a project. But let's just run this. And you'll now see that this test succeeds as well because we said the successful is false, so it throws this error and we do the comparison. So now we're able to see how we can chain and test multiple errors or test errors that are thrown in Swift Concurrency. So I'll be honest with you, with this do catch, there actually is a better way of testing errors that are thrown in unit tests using XCT assert error, which actually tests if an error was thrown. But at the time of this recording, Swift doesn't support Swift concurrency for that. You have to write a wrapper function, and I didn't want to go into that. So this is just a simple way of you basically getting around that until Apple, produces an API update for us to do that in Swift concurrency. So hopefully in Dub 23, we'll get that update. Cool. So in this video, we went over, how we can test asynchronous code. We went over how we can test Swift concurrency, how we can actually test errors being thrown in both Swift and Swift concurrency, and basically discussed things you should look out for when you're actually writing async code as well. So we covered quite a lot in this video. So if you enjoyed this video, I'd love to hear your feedback in the comment section below. Also as well, if you like my teaching style, I actually do have courses on my website you can check out, and you should see it on the screen here. Now, if you want to support me with a monetary value, I'd really appreciate that. And you can do that by leaving me a tip on YouTube or in Coffee, which is in the description box below. Also, as well, if you're interested, you can actually become a YouTube member to help support me so I can continue doing videos like this to teach y'all. And you basically get cool badges as well to show that you're one of my ride or dies. Now, if you don't want to support me with any monetary value, I understand, that's fine. What you can do though to support me for free is by liking, comment, subscribing, and hit the notification bell to get updates for whenever I release a new video, and also sharing the video with people that you think might find this useful as well. I'd really appreciate it. I want to say thank you to all my YouTube members for sticking around and being ride or dies. And I see y'all, I see all of y'all, you know what I mean, my little analytics, I see y'all. So but that's everything from me. I'll catch you in a bit. I hope you enjoyed the video. Deuces.